Let's have a look at rendering a 3D computer graphics scene on the Azure cloud. This is Nozomi-chan. We use her at Netscape for our render testing and benchmarking purposes. This scene is currently being rendered by the GPU in real time. It takes a very simplistic approach to the scene render, essentially just displaying the geometry and textures with almost no complex lighting calculations. We can see that because the lighting is so simple, there's no shadowing on the model in the viewport. It looks rather flat and unrealistic. For example, over here, the hair is not casting any shadows on her face, which reduces the realism. So what we're going to do is we're going to set the render camera to match the current perspective that we're looking at, and then do a quick CPU-based render, which runs all of the lighting and physical calculations that are relevant to the scene to give a realistic output. Here we can see it rendering, and it's taking around 15 seconds on a single core to render a single piece of this image. If we leave it like this, it's going to take forever to finish. So I'll go ahead and speed it up by 500% so we can see how it gets rendered overall. One core will take a single piece of the image, finish rendering it up, and then move on to the next small piece. Once every piece has been completed, we have our final render output. It took the 4-core i7 CPU over 2 minutes to render this very simple scene at 1K. If a 3D studio wants to render an entire sequence for some anime or a movie, they're rendering thousands of high-definition frames just to get a few minutes of footage, and any changes that occur require the sequence to be re-rendered. That's why render farms are so important to the industry, but now that we've moved on to the cloud age, we can move away from expensive hardware maintenance and leverage cloud resources to achieve similar or the same goals. So what we're going to do is throw the same scene up in an automated pool in the cloud to be rendered with Azure Batch. We'll use just 2 nodes for this demonstration, and giving it a meaningful name, tell it to render just 14 frames so it runs in the background while I'm explaining things. Then we have our texture assets over here. These are just checking so that we don't have any pathing issues. And then we set up the environment, which is going to be CentOS on a D2V2 series VM. It'll automatically upload all the textures and scene files to the blob storage, which will then be copied over to the render nodes once the job starts. The render nodes will be in a pool within Azure Batch. So over here we can see that they're now green, which means that they're already rendering. They can be accessed through SSH or RDP to view the logs. However, if we're actually looking for the log files, it's slightly more meaningful to just go ahead and look at the plugin, which gives you the ability to download the relevant files that you want. If we look here, it'll show you a preview of the most recently rendered frame at the top, as well as the button below, which will download all the log files and all the render outputs at once, straight to the path of your choosing. We decided to render a full 240 sequence of this current scene that we're rendering earlier, and it took just 17 minutes with 20 nodes in the cloud, whereas it would have taken our workstation PC over 8 hours to do the same work. And that's the power of Azure Batch rendering.